Okay, this is the section on polynomial zeros of polynomial functions. We've done some of this already. The basic here is you got to figure out what they are. They don't necessarily give you them. So our first problem is 13. So we have g of x equals x cubed minus 4x squared minus x plus 4. Now this one actually, in my book, it hints that I can use grouping. So just so you remember what grouping is, what you can do is you can group two of these, like these two terms together, and these two terms together. And what you can do is factor out the x squared part. So you'll have x squared, and what you're left with is x. And if you factor out x squared here, you get x minus 4. And if you factor out -1, you'll get x minus 4. So it just happens that you have that common factor, and then you can put those two together and get x squared minus 1 times x minus 4. And then you could factor this to x plus 1 and x minus 1. And so you get all the answers. Now the other way you could do it, if you didn't recognize that, is you can think about, what are my possible real zeros? And so you look at the factors of 1, which is 1. So this is the coefficient associated with that, and plus or minus 1. And then for the second part, the last number, you could get plus or minus 1, plus or minus 2, plus or minus 4. So my possible real zeros are these divided by plus or minus 1 from there. So that doesn't really change anything. So you can see that half of the zeros are from this list. So you might try x equals 1 and just try it out. So you take the coefficients from the original equation. So you bring down the 1, then you multiply 1 times 1 is 1. -4 plus 1 is -3. 1 times -3 is -3. Add those together, you get -4. 1 times -4 is -4. You get 0. So we know that x, what that says is x equals 1 is a solution, is a 0, or x minus 1 equals 0 is a fact, well, x minus 1 is a factor. So, and you also know that the equation you have left is x squared minus 3x minus 4, which at that point you could probably do it by observation, just because you've got, what two numbers multiplied together give you -4. Well, -1 and 4, or -4 and the opposite, whatever that was. And because you have a negative sign here, you're going to put the negative in front of the 4 and the positive in front of that one. And so you've got -1, or these are the factors. If you factor it, you get x minus 1 times x plus 1 times x minus 4, which is what you got over there. And the real zeros, that's the factoring. From that, you would say the zeros are x equals 1, x equals -1, x equals 4. So those are the actual zeros. Okay, next one is 26. It says, list the possible rational zeros of f, sketch the graph of f so some of the possible zeros in part A can be disregarded, and then C, determine all real zeros of f. So, yeah, the question is, how do you sketch it without knowing what the zeros are? So what you have is, I forget which is P and which is Q. I think P isn't. P. So P are the factors of the final term. So P can equal plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. And Q is equal to, you got negative 3 there, so it could be plus or minus 1 or plus or minus 3. So those are the P's and the Q's. And so the possible rational zeros, which is the P over the Q, so that's P over Q, is all these by themselves when you divide by 1. So you're going to get plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. And then all those divided by 3. So you get plus or minus a third, plus or minus 2/3, plus or minus 4/3, plus or minus 8/3, plus or minus 16/3. So and so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 2 for plus or minus. So you've got 20 possible zeros, which is horrendous as far as figuring it out. So so you could just start picking ones and, do the easy ones first, plus or minus 1, plus or minus 2, see if those work. What they're asking you to do is to plot it. So let's go ahead and plot it, because we need the zeros to be able to plot it. So you really can't plot it without solving the problem initially. So that means we've actually got to just plug it into the graphing program. So let's see what it was. Negative 3x cubed, negative 3x cubed, plus 20x squared minus 36x plus 16. So you see we've got 3 zeros here. One is at negative 4, one is at negative 2. I mean, one is at 4, one is at 2, and one is at, looks like 2/3. So the easy thing to do would be to just try negative 4 and see what we get. So take the original equation, coefficients, negative 3, 20, negative 36, 16. So 4 is one solution. So bring this down, get negative 12, add these together, you get 8. 4 times 8 is 32. Add those together, you get negative 4. 4 times negative 4 is negative 16. You get a 0 remainder. So what we're left with is negative 3x squared plus 8x minus 4. So what do we do there? Well, again, we could look at our graph and say, oh, it looks like 2 is an answer, and then you could do long division with that. So you'd have negative 3, 8, and 4, 2. Bring this down, you get negative 3. 2 times negative 3 is 6. Negative 6. Add those together, you get positive 2. 2 times 2 is, something's wrong here. Oh, this is negative 4. So 2 times 2 is 4. You add those together, you get 0. And so what you're left with is negative 3x plus 2 equals 0. And so you can solve it and you get x is equal to 2/3. So those are the zeros that x equals 2 and x equals negative 4. And if you tried 1, what you would find out is that you would have a remainder. And you might be able to use that to help guide you. Let's use completing the square on that thing, just because it'll be interesting. It'll be kind of hard, basically. So I just want to show you how it works out in the long run. Keep everything straight. So we set that equal to 0. So what we can do is, one thing is just divide everything by -1, or multiply by -1. So you get that. And then you'd factor out the 3. So you get 3x squared minus 8 thirds x. And then you'd add your 4. So if you take half of 8 thirds, you get 4 thirds. You square that, so you'll get 16 ninths. So we add 16 ninths here. And what we're doing is really 16 ninths. I think you had there. So 16 ninths. So if you take 16 ninths times 3, the 3 you cancel out. And so what you're really doing is you're adding 16 thirds, but I need to subtract 16 thirds to balance everything out, because I added it and I have to subtract it. Now you can collapse the thing, and it's going to be -4 thirds. So it's x minus 4 thirds squared. So we add those two together. This is 12 thirds. If you take 4 times 3, you get 12. So it's 12 thirds minus 16 thirds. So this right here would give you -4 thirds. So when we move to the other side, it becomes +4 thirds. Okay, then we divide by 3, both sides by 3, so you get x minus 4 thirds squared is equal to 4 ninths. Then we take the square root, so you get x minus 4 thirds equals plus or minus the square root of 4 ninths. Well, 4 ninths, square root of 4 ninths is 2 thirds, so we get plus or minus 2 thirds. Square root of 4 is 2, square root of 9 is 3. So then you add 4 thirds to both sides, so you get 4 thirds plus or minus 2 thirds. So one solution is 4 thirds plus 2 thirds, which is 6 thirds, which is 2. And the other solution is x equals 4 thirds minus 2 thirds. So I hit plus or minus. That comes out to 2 thirds, which is your answer. So you can see we get that way. So that's how you do it, completing the square. Okay, the next one is 50, so we're just skipping over a lot here. So 50 says find all the zeros of the function and write the polynomial as a product of linear factors. Actually, 50's not, 50's in the previous section. So use the given 0 to find all the zeros. Okay, that one's easier. So what you have is g of x is x cubed minus 7x squared minus x plus 87, and it says one of the zeros is -3 plus I. So we have this complex number, and because these always come in pairs, complex conjugates, you're going to have -3 minus I is the other one. So what you'll have is you'll have some linear factor times x plus -3. Actually, it'd be not minus. So you'd have x minus the quantity, -3 plus I. And the second factor would be x minus -3 minus I. So these are the factors associated with these zeros. So you have x minus the 0, x minus the 0. So what we can do is you can multiply this thing out and find out what this thing squared, basically what this is. If you have the quadratic term that has only real numbers. So what I'm going to do is expand this out. So you'll do first, so you'll get x squared. Then we'll get x, get a negative sign, x times this. So you get x times negative 3 plus I. And then the outer, still have a negative sign from here, times x times negative 3 plus I. And then finally you get positive, because your negative times a negative is positive, and you have 3 plus I times 3, negative 3, pardon me. Make sure we get the negatives in there. Negative 3 plus I times negative 3 minus I. So you've got negative x times negative 3, negative x times negative 3, so that's negative 6x. And what happens with the I part is you have negative x times I, and then one of these, I did the sign wrong. So this one should be negative I. So I did x times that, which has a negative I, and then this times that, which has a positive I. Anyway, you get negative x times plus I, and negative times the negative is positive. So these parts cancel out. The imaginary stuff cancels out there. And then if you multiply out the last thing, you'll get plus 9, negative 3 times negative 3. The inner and outer cancel out because they're complex conjugates of each other. And then you have negative I squared. I squared is negative 1, so negative 1 times negative 1 is positive. So you'll get plus 9 plus 1. So you get x squared minus 6x plus 10. And then you can you have to use long division here. So you take x cubed minus 7x squared minus 11 plus 87 divided by this quadratic term, x squared minus 6x plus 10. So you say, okay, what do I need to multiply x squared by to get x cubed? Multiply by x, so you get x squared times x, x cubed, x times negative 6x is negative 6x squared, x times 10 is 10x. But I'm really subtracting that, so I'll put the negative sign out in front. These two cancel out. You have negative 7 plus 6, so that's negative x squared. Negative 1 minus, you get a negative 10, so it's negative 1 plus a negative 11, negative 10, which is negative 11. So you get negative x, 11x, and then you bring down plus 87. And that doesn't look good. So let's see where I went wrong in this thing. Oh, it's because I looked. That's 51. Okay. I wasn't gonna. That wasn't working out, so I knew I made a mistake somewhere in this whole thing. So let's just delete that. We'll come back. So if I actually read the problem correctly, you'll see that the solution is 5 plus 2i. So that's 1, 0, and the other 0 is the complex conjugate, 7 minus 2i. Okay, now we're going to multiply those together. But actually we need to put them in factor form. So it's going to be x minus 5 plus 2i and x minus 5 minus 2i So can we get x squared? If you remember from the previous step, when we did the inner stuff, the I parts canceled out, and you'll end up with a -5 and a -5. So that's -10x from the inner and outer stuff. And then here you get, when you do FOIL on these two, you'll get 25, and then the inner and outer will cancel out. And then we have 2i times -2i. So that's going to be -4i squared. But I squared is -1, so you'll get +4 from these two. So let's just put that in there. So you get 25 from here to here. The inner and outer cancel out. And you get +4 for the last one. So I think the answer is going to be that. Actually, it's going to be positive because you got a negative times a negative. So that's positive. So as long as it's positive. I knew I made a mistake because you never have a negative sign here if you end up with complex roots. Okay, so now we do the same thing we just did. So you got x cubed minus 7x squared minus x plus 87. Divide that by this. So you multiply by x. So you get x cubed minus 10x squared plus 29x. You're really subtracting that. Goes to 0. -7 plus 10 is 3x squared. Here we have -1 minus 29, so that's going to be -30x, and then you bring this down plus 87. What do you need to multiply x squared by to get 3x squared? Well, it's plus 30. So you multiply that, you get 3x squared minus 30x plus 87. But you're subtracting that, and you get 0. So the remainder is 0. So my third factor is x plus 3, or x equals -3. So that's my factor. So that one I know is right now. Okay, next one, 53. So it's in that same group. It's also involving imaginary numbers again. F of x equals x to the 4th plus 3x cubed minus x 5x squared minus 21x plus 22. So we do the same thing that we just did previously. The 0, so the two zeros that they give you, well, they give you one 0, but the other one is implied because it's a complex number. They always come in pairs. So it's going to be -3 minus the square root of 2i. So that's my other complex thing. So what we do is the factors associated with this are x minus -3 plus the square root of 2i, and the second factor is x minus -3 minus the square root of 2i. So using FOIL, and I'll do this one out completely, you're going to have x times x, which is x squared. Let's do the outer first. So you're going to have -x times -3 minus the square root of 2i, and then you'll do the inner, which will be negative still. So it'll be -x times -3 minus or plus the square root of 2i. So that's the outer, that's the inner, and then you have the product of these two. They're both negative, so that'll end up being positive. And then you multiply these two out. And what'll happen, all the imaginary terms are going to drop out. So like before, you've got negative x times negative the square root of 2, and you've got negative x times plus the square root of 2. So those two are gone. And what you've got left is negative x times negative 3 plus negative x times negative 3. So those two are going to become positive 6x. The last part, you're going to have negative 3 times negative 3. The inner and outer cancel out because they're complex conjugates. And then you get minus, because you got plus times a minus. So it's minus the square root of 2 squared times I squared equals 0. So what do we get? We get x squared plus 6x plus 9 minus 2 times negative 1, because I squared is negative 1. Square root of 2 squared is 2. So this becomes positive. So we add 9 and 2, we get 11. So we get x squared plus 6x plus 11. So that is the quadratic part. So then we have to take the original expression, x squared plus 3x cubed minus 5x squared minus 21x plus 22, divide that by x squared plus 6x plus 11. So to get x to the fourth, we're going to have to multiply this by x squared. So we'll put x squared here. X squared times x squared is x to the fourth. X squared times 6x is 6x cubed. X squared times 11 is 11x squared. Let me subtract each item. So that goes to 0. You have 3 minus 6, which is negative 3x cubed. We have negative 5 minus 11, which is negative 16x squared. We'll bring down the next one, which is negative 21x. Okay, what do we need to multiply x squared to get negative 3x cubed? Negative 3x. So we'll get negative 3x cubed there. Then you have negative 3x times positive 6x, that's negative 18x squared. And negative 3x times 11 is negative 33. Negative 33x. Okay, but we're really subtracting that. So these go to 0. You get negative 16, positive 18, so you get 2x squared. And negative 21 plus 33 is 12. So that's plus 12x. And then you bring down 22. And if everything's perfect, this should end up with a 0 remainder, which it does. So what do I need to multiply x squared to get 2x squared? 2. So 2 times x squared is 2x squared. 2 times 6x is 12x. 2 times 11 is 22. I'm subtracting this, so everything disappears. 0 remainder, which means these are, well, means this is a factor, which can then be factored into those. And then the remaining equation, which was up here, which is x squared minus 3x plus 2, can be factored into x minus 2 times x minus 3, makes minus 1. So you get x squared minus 2x minus 1x is minus 3x. Negative 2 times negative 1 is positive 2. So the zeros are the original one that was given, negative 3 plus the square root of 2i. There is negative 3 minus the square root of 2i. And then we have x equals 2 and x equals 1. And those are the 4 zeros that we have. '59. Find all the zeros of the function and write the polynomial as a product of linear factors. So 59 is x to the 4th minus 81. Now if I asked you what was x squared minus 81, you'd say, oh, it's x plus 9, it's x minus 9. The inner and outer cancel out. So the same thing applies here. But you've got an x, instead of x squared, you have x to the 4th. So it ends up being x squared plus 9 and x squared minus 9. And you can factor the second term again into x plus 3 and x minus 3. Now, this one you've got to use, it's going to be imaginary. So what we do is we set that equal to 0, and then you subtract 9 from both sides. You take the square root, so you get plus or minus the square root of negative 9, which is equal to plus or minus 3i. So those are 2, and these are the others. Those are the zeros. The zeros here would be x is plus or minus 3. So we have 4 zeros, which are x plus or minus 3, and x is equal to plus or minus 3i. Next, 63. So what have we got? It's g of x equals x cubed minus 2x squared minus 11x plus 52. That's not the right problem. I jumped ahead. My brain is looking at the wrong problem. At least I recognized it earlier this time. 63. So you do have x cubed minus 6x squared plus 13x plus 10. So the possible rational zeros are going to be plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Because the p's would be plus or minus 1, and the q's would be plus or minus the factors of 10. So you got to choose one of those. Let's try 1. Just see what happens. So put the coefficients associated with the original third order polynomial in there. So x equals 1, bring this down, 1 times 1 is 1, and then you end up with negative 5. 1 times negative 5 is negative 5. Add those together, you get 8. 1 times 8 is 8. Add those together, you get 18. So obviously 1 is not going to work. So then you could try negative 1. Let's try that. Bring that down. 1 times negative 1 is negative 1. Add these together, you get negative 7. 1 times negative 7 is positive 7. Add this together, you get 20. 20 times negative 1 is negative 20. So you get negative 10. Now, what you can see is that one of the zeros is between negative 1 and positive 1, but it's not one of our rational zeros. So then I try 2. Let's just try 2. See if that works or not. And once we get one of these, the rest of them are going to be not as hard. So try 2. So bring down 1. 2 times 1 is 2. Add these together, you get negative 4. Multiply these together, you get negative 8. Add those together, you get that should have been negative 10. So let's let's fix what we had down here. So that'd be negative 10. So there you would get negative 2, and here you get negative 30. So actually, what you're seeing is you're positive. You actually, oh, that's negative. So you're negative, and then you're less negative. So it looks like, just from this, you'd expect 2 to work. And if you put the right number in here, you will. So 13 minus 8 is 5. 2 times 5 is 10. Add those together, you get 0. So what you're left with is the equation x squared minus 4x plus 5 is the remaining one that we need to factor. And you think, okay, well, the factors of 5 are 1 and 5. The problem is it's positive. So if you did 5 and 1, you add them together, you get 6. That's not going to work. So I have to use something else. So we use completing the square. So we take negative 4 divided by 2, we square it, which is going to be plus 4. And we have to subtract 4, and then we add the 5 that's from the previous step. So we add 4 and subtract 4. So this can be reduced down to x minus 2 squared plus 1 equals 0. Subtract 1 from both sides. Take the square root. Replace square root of negative 1 with I. So you get x is equal to 2 plus or minus I. So that's the other two solutions. The other one was x equals 2. So this equation, if you plotted it, it would only have one x-intercept and no other x-intercepts. And I think the final one here is 66. So you get h of x equals x cubed plus 9x squared plus 28x plus 6. Double check that. Okay, so again, the possible real zeros are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Because the p is 1, so the denominator is plus or minus 1, and then the factors of 6 are that. So again, we'll try positive 1. So we get 1, 9, 28, 6. So bring that down. And you can almost immediately see this is not going to work because these are all positive, so they're just going to keep adding on to each other. But we'll go through one time just to show you. So add these together, you get 10. 1 times 10 is 10. Add this together, you get 38. 1 times 38 is 38. Add this together, you get 44. So obviously that's not going to work. And if you do any positive number, they're just going to keep adding on. So it's going to have to be negative. And since this number is kind of large, I'm going to try negative 2, just to see what the heck happens. I have not worked this problem, so I don't know, what I need to do. So that's just how I would think about it. And what I'll find is if this goes down, if negative 2 becomes a negative number, then I know it's probably going to be negative 1. Okay, so bring down the 1. Negative 2 times 1 is negative 2. 9 and negative 2 added together is 7. Negative 2 times 7 is negative 14. Add those together, you get 14. So you have negative 2 times 14, which is negative 28. And add those together, you get negative 22. So that's looking awfully like the answer is negative 1 to get the first factor, or the first 0. Okay, bring 1 down. 1 times negative 1 is negative 1. Add these together, you get 8. Negative 1 times 8 is negative 8. Add those together, you get 20. That's negative 20. So you get negative 14. So it doesn't look like those are going to work. So let's keep going. We've got a few more left here. Got negative 3. Let's see what happens there. So I got negative 24. Oh, it's getting even worse. So let's try negative 6. See if that works. Now I'm looking back, make sure I didn't do it wrong. I did do it wrong. Okay, sorry about that. So my original equation was wrong. X cubed plus 9x plus 27 plus 35. So let's delete that, and we'll delete that whole page. So we all make mistakes like that. So again, hopefully learning experience here for you is if you do make, sometimes you do copy things down wrong. And what I was seeing was that as I went to more negative numbers with that equation, that I was getting more negative. It wasn't going in the right direction. And then I thought, this just doesn't make any sense. So sometimes you just have to think, oh, it makes sense. Maybe I should look at what I did. Okay, so here we get plus or minus 1, plus or minus 5, plus or minus 7, and plus or minus 35. It's very unlikely it's going to be 35. It's also not going to be positive, because we saw that if all these terms are positive, you're not going to have a positive 0. So let's try negative 1. So that is 54. So that's not going to work. Let's try negative 5. Okay, bring that down. Negative 5, 4. Negative 5 times 4 is negative 20. Get 7. Negative 35. Oh, thank goodness. I finally got worked. That one finally worked out. Okay, so x equals negative 5 is 1, 0. And what we're left with is x squared plus 4x plus 7, which looks like we're going to get an imaginary result. But let's see what happens. So we use completing the square. So we put a space here, take half of 4 and square it, which is 4. So you add 4, you subtract 4, you add 7, and you set that equal to 0. You take these 3 terms, break that down to a complete square. This number 4 over 2 is the number used there. And we have plus 3 is equal to 0. So then you subtract 3 from both sides, take the square root, so you get x plus 2 is equal to plus or minus the square root of -3, and we replace that with the corresponding I. So it's plus or minus the square root of 3i. And then finally subtract 2 from both sides, so you get -2 plus or minus the square root of 3i. So there's two solutions, and the third solution is this one. So again, there's only one x-intercept because there's only one real 0.